Hi everybody, I'm Zarek Holvey and this is Sarah Studer. We're from DOE's Fuel Cell Technologies office, and today we're just across the street from DOE headquarters here in the Smithsonian Gardens, and we've got a little fuel cell demo for you here today. So Sarah, why don't you take it away?
Great. So today I want to talk to you guys about fuel cells and hydrogen. So fuel cells are these really cool devices that take the chemical energy in fuels and convert it to electrical energy in just one step. They're really clean and really efficient. So we have this system here today to tell you about a little bit about the various technologies. Over here we have a fuel cell, but first to run it we need to make fuel. So I'm actually going to start over on this end. So fuel cells can use a lot of different fuels. They can use natural gas, they can use biofuels like ethanol, but the Fuel Cell Technology Office focuses on using hydrogen as the fuel source.
And so here we're making hydrogen, obviously using this little solar panel. How other ways can we get hydrogen?
That's a great question. So I actually support the hydrogen production team, so this is my main area of interest, and one of the things that really excites me about hydrogen is that we can make it from so many different resources available here in the United States. So you can make it from fossil fuels. Most of the 10 million metric tons of hydrogen that are produced in the United States today are produced from natural gas. But you can also use renewable resources. For example, you can make it out of biomass. There's a lot of different pathways. Some of them are ready today to be used, like natural gas that I mentioned before. Some of them are longer term. I'm a microbiologist, so I'm actually interested in getting microbes to produce it for us. But other people are looking at, in the longer term, how we can use sunlight to directly split water. But here, like you were saying, we are splitting water using something called electrolysis. So we're basically just hitting water molecules with electricity. And how this works is you can use pretty much any electricity source. Here we have a solar panel and a nice bright sunny day, and that's providing electricity to this electrolyzer. Now it's using that electricity to split water, H2O, into O2 and H2. So these bubbles here that look like air, those are actually pure oxygen and pure hydrogen. Now we don't need to keep the oxygen, but we are keeping the hydrogen here so that we can, and now what's exciting is that we've stored that solar energy and converted into a chemical fuel that we can store. So if it gets too dark for the solar panel to run, we still have that energy stored. This also means that we can move it around. So you could imagine making a lot of hydrogen in a central location and then putting it into trucks or pipelines to take it to a city where there's a lot of people using hydrogen in their cars or other applications. So for those of you just joining us here, we're from the Fuel Cell Technology Office, and we're talking to you guys about hydrogen and fuel cells with our demo system here. I've made some hydrogen and we've stored it. Now in the real world, we would probably be taking this somewhere or storing it for later, but here for this demonstration, we're putting it straight into this fuel cell. Now fuel cells are kind of like batteries. They're going to be providing power, and with fuel cells, as long as you keep providing them with fuel, they'll keep providing power. Also, like a battery, there's two sides. On this side, we're putting in the hydrogen fuel. On the other side, there are some slits that are letting air in, and with the air, oxygen. And the way that the fuel cell is generating electricity is through the reaction of combining the hydrogen and the oxygen to make water again, H2O. And so how that works is that on this side, there's catalysts that help rip apart the hydrogen into electrons and protons. So electrons and protons are parts of atoms, and they're charged. They tend to try to recombine with things, and over here, there's that oxygen that they can recombine with to make water. Now, but to do that, both of those have to get over to this side. And managing those pathways is how the fuel cell is able to get electricity out of this reaction. So in the center, there's a membrane. It's like a net, and it only lets the protons go through. So the electrons have to find another path. So we've connected the two sides with wires. So to get from one side to the other, the electrons have to flow through the wires. And electrons flowing through wires is what we call electricity. Here, we're just using it to power this fan. So there's a number of reasons why we're excited about fuel cells. Two of the important ones are, first, that with only one step involved and no combustion, it's a really efficient reaction. So, for example, a kilogram of hydrogen has the same amount of energy as a gallon of gasoline, but in a fuel cell car, that kilogram of hydrogen is actually going to get you about twice as far as a gallon of gasoline in a regular internal combustion engine. So you can use more of the energy that's actually in that fuel. Secondly, it's a really clean reaction. When you're using hydrogen, the only outputs are the electricity, heat, and water. So it's very, very clean.
So you alluded to scaling these up to use in actual vehicles.
Right.
And you guys may have seen some of our other Facebook Live posts or videos on the Facebook page where we have some fuel cell electric vehicles here in DC, and we do some ride and drive events with those as well. But beyond vehicles, what are some of the other applications that you could use fuel cells for?
Right, so these scale really well. So they can scale down to something small enough, like to be like a portable phone charger or portable power for other applications, but they'll also scale up to be big enough to provide power for buildings or backup power for cell phone towers and places like that. So they scale pretty well.